review the coursework of the previous course instead of using the coursework of computer and So we will make coursework from last course for demo or for better understanding. Maybe the real coursework for this course may be different. Is that okay? Alright, so we will begin with the lecture first. Okay, hello class. Today we will have an introduction about the rapid application development. We can call it RAD. RAD is a concept that many other methodologies were developed based on RAD. So, in your life, as an IT guy, you will have about the word RAD or IRD or rapid application development for many times. And maybe some of you have a basic understanding or the fundamental of how RAD works, but the history how it defined you should need to know as well. And RAD was defined by James Martin in 1990. James Martin used to be a software engineer, I'm not sure, an engineer at IBM Corporation. And someday he defined a new concept of how to implement an information system that can meet user requirements, that means meet high quality and deliver within budget and on time. That is the early concept about RAD. In 1990, James Martin published his concept to the world as a conference about software development lifecycle. However, at that time, what he said about is not a methodology. That is a concept, only a concept. So, from the time 1990s, remember, rapid application development didn't mention about any specific methodology. It was actually just a concept. And according to this concept, the product can be developed faster with higher quality standard. The early concept of RAD focused on two main points. The first point is how can we create an information system in a faster time, and how can we create an information system that meets higher quality standards. And the high quality standards will be archived to read two spots. First one, the knowledge of the user and development team will be increased time after time. That means, according to RAD, user and developer don't need to have fully understand about an information system before making it. It is totally different from waterfall. As you remember about the waterfall's traditional software development lifecycle, in order to start another phase, they have to complete the previous phase, complete 100%. What does that mean? That means user and developer, sorry, not user here. Developer must have fully understand about what he did before he started. In RAD, it's different. RAD doesn't require developers to have fully understand about a system. They just have the very basic understanding to start off a new project. And time by time, their knowledge about the system will increase. And when their understanding about the system will increase, they will make a better system, better and better every day. And another point in red concept is user. User become an integral part of the development team. You can see the concept here is different from traditional software development lifecycle. According to traditional SDLC, in order to implement an information system project, there was only one role. That is the development team role. And user play no role in that project. That's why in the first day, we have learned many systems, huge systems, take a very long time. A lot of people and huge money, 100 million of pounds, even billions of pounds, but they still fail. One of the most important reasons is that they didn't integrate user into the development team. And this is the lesson learned. By learning that lesson learned, Red proposed a new idea. User must be an integral part of the development team. So remember two main things about Red concept. Red concept focus on making faster and higher quality standard. And in order to adapt high quality standard, developers don't need to have full understanding at the beginning. They just need enough to start up a project. And the second point is, user must be an integral part of the development team. There are new points in Red concept. And in Red, they are creating high-level requirements at the beginning of the project. As I said before, the developer don't need to have full understanding. So, people will agree on high-level requirements at the beginning of project. Do you understand what high-level requirement is?
That means the main object. The main
Not
object
really.
is
For the user requirement, we have to differentiate. There were two levels. The first level we call high-level requirements. The second level we call it detailed level requirement. High-level requirement does mean general understanding about the project. In high-level requirement, there was not any specific or detailed requirement. They are just general requirements. For example, when I said, I want you to create for me a student management system. And that system will include some function that can manage students and their grades. That are high-level requirements, very high. They don't focus on how the screen looks like, how many detailed functions there are in that system. What are the non-functional requirements? We don't mention about that. Because at the first time, in many projects, even many users, they don't even know what they want. User will find out what they want time by time. And the same to the development team. They will get higher understanding time by time. So, the next point about Red is, people agree on high-level requirements before starting up a new project. So does it make any disadvantage? Because you have the high level requirement only, you agree on that. So you may be wrong, and everything has to be thrown away and you start up again. But however, it doesn't take most of the time, many resources. You still have time and resource to do it again. So how can people come up with the high level requirement? They're using workshops or focus groups to get them initially. Have you ever attended any workshop or focus group? We used to have about a workshop many times. So what is that? Is that somewhere in a factory or in a manufacturer? No, workshop is a kind of meeting. But in that meeting, only key person of the development team and key person inside of user will meet together. So what do they do in that meeting? The development team will try to learn as much as possible about user requirement. That is workshop. And they focus on some very specific scope of the project. For example, if we are saying about student management system, in the first workshop, people will talk about general requirements. In the next workshop, they will focus on the function they will work on, but in general view only. And after that, refining them during the development cycle with the user. How can people refine user requirement? People will create something called prototype. And after they finish one prototype, they will give that prototype to the user. The user will look at the prototype and propose their evaluation assessment, and then send back the feedback to the development team. And after gathering feedback from user about the first prototype, the development team will create another prototype which is better than the other one. So, the main idea here is Brad using the concept of prototyping to work with user and develop or revise low-level requirements. What does that mean? That means in Red, firstly, they agreed on high-level requirements. Then, they use the prototype to revise the high-level requirement with the support of user to make it become low-level requirements or detail-level requirements by looking at the prototype. And I remember one of you used to asking me about what is prototype, right? So here is the concept of prototyping. Have you ever seen something like this before? Yes or no? What do you call this one?
This is a mock-up design.
Yes, in term IT we call it mock-up design. Sorry, in web design we call it mock-up. Anyway, we call it sketch. Sometimes we call sketch or high-level requirement. This is a low fidelity prototype. And you see here, these are the three illustrate different streams of an application work on a mobile phone. And people will show the stream to user by using this fade mobile phone on the screen. For example, when they are saying about the product page, they will move the mobile phone to the product page. For what? So that user can see how product page look like. This is a kind of low fidelity prototype. Are the general requirements. So by looking at this prototype, user will contribute their assessment or evaluation. For example, they can say that I don't want the button will be placed here. I want the button will be placed on the left side. I don't want the background screen is white color. I want the background screen is green color. And what is that function? I didn't ask for that. And where is another function that I asked before? Where is it? That are their assessment, their feedback. And then when we move next to another screen, again, user will provide the feedback. Understand it? However, this can be considered like low fidelity prototype because we cannot see the interaction. We cannot see the interaction here. It interact between user and the application. And the next part of our graph is it uses a regularly paced, tightly defined schedule. Schedule in rest is very, very tight because the minimum period of time that you have to deliver one release is 2 weeks only. And the maximum time to deliver something in web is 4 weeks only. In red, they never accept something longer than 4 weeks. And this is called time boxing. In order to support how you can meet with that time deadline, 2 weeks, 4 weeks, we have to try to maximize the automation by using automation tools from an analysis phase to design phase to implementation phase. And now that we have some case tools that can help us to generate code. For example, after you finishing the use case, that case tool, I don't remember exactly the name, but maybe Poseidon, I'm not sure. After you finishing the designing of use case, it will generate the initial code for you. And it will generate ER, class diagram for you as well. You will have the database schema. You don't need to do anything more. Understand? And this is the example of one time boxing model. Why do we call this time boxing? This one called time boxing. And this one this is the start date of the development cycle. And this is the deadline of the development cycle. And you can see the whole development cycle here is only 3 weeks. The whole cycle for development only 3 weeks. This one on a time box. And from the start date, we have to specify goals and targets for the whole time boxing. And by the end, by the deadline of the development cycle, the set of requirements must be fulfilled. That means, for example, you have 5 requirements in one time box. So that means by the end of week 3, you have to complete all of them by requirement. And inside the time box, you can see we will this start from week 1 to half of week 2, and this start from half of week 2 to the end of week 3. This start from half of week 1 to the end of week 3. This is the specific period in which requirements will be built, and here is the set of requirements assigned to person. That means, for example, the first developer will be assigned this requirement, 3 functions. The second requirement, 2 functions here, and the last requirement will be assigned to the last developer or the last group. Maybe 2, 3 people will implement that 5 functions here and here. And the whole here, time boxing. Understand? Any question? So, how can we devise? This is just a slide of requirements only. How can we divide a system with different modules into time boxing? Let's have a look. From here we can see there are 3 phases with different states. The first one, we get something. This is the whole of our project. Our project may include different things. At this time, we have the initial project and we don't know anything about it, but we should start it. So, after analyzing the project, we will have the project requirements. And we will identify modules, different modules for that project. For example, here we have this module, and this module, we have a lot of things here. And this module, the integration of this module combines a fulfilled information system. But is that enough? No, the next step, we have to cluster them. How to cluster requirements? Cluster requirements, in other words, we can say grouping requirements. You may have many kinds of grouping or categorizing. Vertical categorize or horizontal categorize, it depends. However, in this simulation, we will use color to illustrate our categorizing. For example, here you can see the purple color represents for a model. And the green color here represents for 3 models here, have the relationship. And the pink color here represents for 3 models have the relationship. They are in one group. Or they are in one category. And we have yellow color here, again the same. But after categorizing those, will we implement all of them? No, we don't. Because we are following red, we don't have time and we cannot implement the whole system at one go. So what do? We select the scope that will be fit for our time box. And this is scoping for the development cycle. That means we try to create a boundary or the scope for one development cycle. What do we do in one development cycle? So here, we will take green color, dark yellow, pink color, and this is maybe blue and blue color. That means we will take this one model, 2 model, 3 group, 1 group, 2 group, 3 group, 4 group. We will take out 4 different groups or 4 different categories of modules to implement. See? We have scope in here. And what we do next? We cannot implement this one and then this one and then this one and then this one. Because we are differentiate them by color. We categorize them by color now with time box stuff. For example, you can see here, this is the second grouping. Green color, one time box. Yellow color, these two are similar, are the most similar. We take them together. Then we take one time box, another time box. Another time box for this yellow only. And these three blue color, they are minor. They request not very short. We don't need much time to spend for it, so we group them on three in one time box. And these two on two purple in one time box. What does that mean? That means in one big time box, we divide that time box into smaller time box. See? For example, in this period of time, we will try to implement green color. And after finishing green color, we start yellow color for this one and blue color. And before we finish blue color, we will try to start the second green color. And after finish blue color, we will continue with pink color. And by the end of this time box, you see, we will complete this curve. And after finishing this time box, again we choose another modules, another group of modules to scoping down. Understand? In terms of management, project management is quite abstract. But the main point you should remember is we have to start create a boundary for what we will do in one time box. And then group them or categorize them, the similar model or similar function into one group or one categorized. And we have two different techniques for categorizing. Vertical or horizontal. Vertical does mean expand the function. Horizontal expand the function. And vertical make it live. Okay.
Cho em hỏi bằng tiếng Việt này.
Okay.
Tại vì anh thấy cái này á, ví dụ như những cái project em đã trải qua á, thì cái thời gian đầu tiên mà lúc mà cái time box đầu tiên á, nó bị tốn thời gian quá nhiều vô cái chuyện này. Tại vì rõ ràng là đầu tiên mình là general requirement cho nên là nó không có rõ, mà đã không rõ cho nên là nó cứ ngồi nó chẻ này ra, nó chẻ rồi xong rồi cái nó lại lên kế hoạch rồi nó lại là thử, có nghĩa là giai đoạn nó giống như đi thử vậy đó, nó thử xong rồi cái nó quay lại cái nó sửa lại, thành ra là cái giai đoạn này nó kéo dài vậy thì có đúng không, hay là bắt buộc là ở cái giai đoạn đầu nó phải đúng một cái time box vậy?
You want me to answer Vietnamese or English?
Up to you. Nó tiếng Việt cho
hiểu hả? Cái lý do mà em nói ra nó có một cái lý do chính, đó là trong team của em nó thật sự là chưa có hình thành một cái red team. Red team là nó có một cái kỹ năng gọi là red skill, và trong đó tập hợp các cái key person, có nghĩa là những người phải có kinh nghiệm về cái dự án tương tự như vậy. Ví dụ như em đang làm lĩnh vực healthcare thì phải có những người ở dự án đã từng làm dự án healthcare để họ estimate cái thời gian cho một cái time box chính xác nhất, và đỡ là mất thời gian, nó không bị kéo dài ra. Còn khi mà chúng ta thiếu người, hoặc là người ta không đủ cái kỹ năng về quản trị dự án, hoặc là không đủ kỹ năng để hiểu cái industry mà mình đang làm đó, thì thông thường thời gian đầu sẽ mất rất là nhiều thời gian để mà tìm hiểu nó và định ra một cái time box. Bởi vì khi mà chúng ta định ra cái time box để mình làm thì chúng ta cũng có xu hướng tự vệ, đó là vì không chắc ăn là như đó làm xong chưa, cho nên cố tình kéo dài ra. Tuy nhiên nó có những cái kỹ năng để mà backup, và trong nhóm nó sẽ phải có tối thiểu là phải có PA, phải có PM của phía mình, phải có key user của khách hàng, phải có team leader, tức là technical architect của mình. Thì tất cả những người đó ngồi họp với nhau ở trong workshop thì nó mới ra một cái estimate về cái thời gian cần thiết cho một cái time box nó chính xác.
Vậy còn đối với những cái task mà như cái màu tím thì nếu mà nó kéo dài, chẳng hạn như nó kéo theo chiều ngang mà nó quá dài, nó có thể mấy cái time box rồi.
Cái này.
Dạ. Khi mà đem xuống vậy có nghĩa là rõ ràng là nó sẽ bị overlap qua cái time box khác, đúng không? Đó là mình vẽ ngắn thôi, ví dụ như nó còn những thứ mà nó cứ kéo dài. Nhưng mà ý là ở mỗi một cái điểm kết thúc của một cái time box vậy thì mình sẽ có một cái báo cáo gì, tại vì thí dụ như những cái dài vậy nó sẽ liên quan
đến cái dài này mình phải chia nhỏ ra, mình phải scoping nó lại. Ví dụ như nếu như mà cái này á, mình dự đoán được là nó sẽ kéo dài quá, function nó nhiều quá, thì lúc mà mình làm scoping á, mình sẽ cố gắng chia nhỏ nó ra nữa, chia nhỏ nó ra nữa để nó phù hợp với thời gian của năm số. Thì sẽ có một số cái trường hợp là kể cả khi em chia nhỏ ra thì đến cuối một cái release mà chưa hoàn thành hết được nó, thì lúc đó nó sẽ phải nhảy qua một cái iteration khác, chứ trong cái iteration một đó là không được. Thì nguyên tắc của chúng ta khi mà chúng ta phải chia nhỏ đến mức không thể chia nhỏ được nữa. Cái này chỉ là cái hình nó minh họa các cái size khác nhau. Understand? So that's why we say that Red will take an iterative approach and incremental approach. Iterative approach does mean there are some activities will be happen by loop. That means it will be implemented again and again and again through different iterations. And incremental approach, that means by after each increment, the project or a model will be improved again and again. It will be bigger. See? However, please note that all of these things are just concepts suggested by the Asian approach much later. And there are no new concepts in the Asian approach, they are based on Red. Many methodologies following Asian approach, but the basement of Asian approach is Red. Here are the 4 essential ingredients of Red. You can see here, rapid application development is built by 4 columns. The first column is tools, the second column is people, third column is management, and the last column is methodology. They are 4 main columns to build up a Red. And James Martin described 4 essential aspects of Red are following. Firstly, Red and tool. As I said before, we will try to maximize automation rate in our Red project. So we will try to use automation tool as much as possible anywhere. Red lifecycle, so that Red lifecycle depends on automated tools and development processes and maximum degree of automation. For example, we don't code by hand. We will code by computer, by using some tool to generate code for us, and we just fix it. We don't run manual tests, we run automation tests. And Red tools require some tools like case tool, prototyping tools, and interactive environment can be used by our life cycle. Can you suggest me any interactive environment? That means in an environment that includes everything, workspace, coding, user interface design, library, anything in there. Like Visual Studio, right? Users? That is an interactive environment. It has everything in there except automation. Anyway, you can use Visual Studio to create automation script tag, but you cannot run automation tag by Visual Studio. You have to use some other support application and software like Testing Director or WinRunner or something like that with Dashboard. And we know that nowadays there are many tools on the market. However, many of them are inadequate for fast development life cycle. How about ready people? As I said before, users become an integral part of the development team. So REST is highly dependent on people. People here is about user and about developers. However, with developer or user, they must have specialist REST skill so that they can become a member of REST team. One important thing is that not every people can become a member in REST team. They must have REST skill. And these people, including user, management representative, system developer, project management staff. We will have a look at REST skill later. And REST and management. The management here in REST, remember one thing, is not about managed people. The main management skill in REST is manage prototype. Because REST is implemented by time box and delivered by iteration. After each time box, you must have something to deliver. And after each iteration, you must have something to release. And all of those deliverables depend on prototypes. So that means you may have hundreds or even thousands of prototypes without or very least documents. And small and the design red team is very small. So when we are saying about management in red, we are not about human resource management. We also not saying about document management. The only thing need to be mentioned about management in red is prototyping management. Do you understand? You may have hundreds or even thousands of prototypes. So if there is a problem, or if there is a defect, how can you trace back that defect belongs to which prototype? For example, you are staying at iteration 5. And up to now, you have more than 300 prototypes. And someday, customer report you a defect. And you find out that defect comes from the iteration 3 at the time box number 2, for example, like that. How can you take out that prototype to figure out is that the real defect? If you don't have the management skill for prototyping, you cannot do that. So again, red management is about prototyping management knowledge. And methodologies. To acquire good result on information system organization, Next methodology that suits both its environment and its tool set. Methods is the way how you can use a tool in that environment. For example, we have the method how to riding motorbike under the rain, right? From not to be slipper. So in this case, we see the environment is this is raining, and the tool here is a motorbike. And you must have the methodologies how to run the motorbike in the rainy day. The same thread. It needs a methodology. How to use tool, how to maximize the benefit of tool in an environment. However, in the time when James Martin success about red concept, there was no methodology to support red. However, in 1994, with the development of the DFM that we have reviewed the last day, remember? This become a methodology that can support red concept. However, the SDM has been refined many times since 1994. Red quality, according to traditional view. If you develop something quickly, that means you will sacrifice some of the quality. Do something quick, low, you will pay up by quality, or quality become lower. However, in many IT projects, quality is the key to success of any IT development project. However, James Martin suggests that high quality, lower cost, and rapid development go hand in hand. If an appropriate development methodology is used, that means, in other words, if we have an appropriate methodologies, we can create an information system that meets high quality, that can be developed fast, and it can deliver within budget, low together. And this is the spirit of RED. When we are saying about RED, we have to understand about the spirit. The spirit is, RED is about high speed, high quality, but lower cost. In Vietnamese, we can say that ngon bổ rẻ nhanh. This is a very new, very advanced concept about developing an information system, and from that time, that's why RED becomes so popular, because everyone wants to have a system with high quality, deliver in a very short times, and especially they don't have to pay a lot of money. So, why RED is increasingly important to the industry? Firstly, because it responds to user. We have learned from the first day there was many information system project has been failed because one reason, it didn't meet user requirement, or it didn't do what the user wants. So the first reason for RED becomes so popular is that it responds to user. So user participation is recognized as an important part in problem definition and functionality design. And key part of red philosophy is user participant throughout the development cycle. It's different from traditional life cycle. From traditional life cycle, developer didn't meet the users. In red, from the first day, the developer had to sit down and work with the user until the delivery date. So that's why people saying that user becomes an integral part of the development team, or user becomes a member in the development team. When we have problem, we ask user. When we want to implement a new function, we ask the user. When we finish a function, we give it to user to review and give us the feedback. And then we based on user feedback to create something else better. Okay? So that's why in red, it's empowering the client is fundamental principle of red. That means we give power, we share 50% of our power to customer. Before, customer had no power. Even we create the system for customer, but they have not any power to provide the ideas. It's different in red. Client is power. If they don't agree, we cannot make it. If they don't agree on some function, on some effect, we cannot deliver it. And prototyping will be built based on user and enable feedback from user at every stage of the development, from analysis to design to implementation to testing. Every phase we're asking for user feedback. So people will asking me, how can user work with us at implementation phase because user cannot code it, right? But it's not true. In some critical project, you can see that on one desk, on one working desk, there are two people working on the same computer. One is developer and another one is user. The user sits next to the developer to fix that, to help them, to give them the ideas. And we have some development activities like JAD. JAD is the abbreviation for Zone Application Development, and in some documents it say that Zone Analysis Development. However, JAD is some kind of like workshop, and key person of two sides, customer side and development team side, we're sitting together and try to resolve the problem. Review walkthroughs. Walkthrough does mean people will review every function of a project, of a system, from the starting to the ending. The next thing is modern business climate. That means according to the modern business nowadays, it changes every day. The business environment changes every second. Technology changes every second. That's why no one wants to wait up to 1 year, 2 years, even 10 years for a product. They want to see something fast. They want to see something rapidly. So development projects with long life cycle are unacceptable. Never be accepted. much from 2 weeks to 4 weeks. Later than you cannot accept it. Also, unacceptable to deliver system that don't meet the needs of user because user have 50% power in a successful information system process. That's why, have you wonder why? For example, do you know about Samsung mobile phone? Yes or no? Do you know Samsung mobile phone?
Yes.
Yes. Do you see any strange thing about Samsung mobile phone? Have you used Samsung? No. Do you keep an eye on Samsung mobile phone? No. If you keep an eye on Samsung mobile phone, you will see that they release new products in a very, very short time. Right? 2 weeks, 3 weeks, 1 month, they have new product continually. Never stop. Forget about marketing. About the market only, about the development only. We can say that they try to create project to release new product in a very short time, in a very short time box. Because they know that their user, their customer don't want to wait for a very long time. Nowadays, you cannot let the customer wait 1 year or 2 years and release a new product. Customer will change their mind and use another brand. Right? For example, before when iPhone let people wait for 1 year or even 2 years to release a new iPhone, that is the backdoor for Chinese mobile phone to grow up like Xiaomi, like Huawei, like Samsung. So don't let any backdoor for the customer run to another factory, another producer. And before we come with the suitable project correct environment, I want to show you. I want to show you an example of prototyping because the main core of every grad project is about prototyping.
One is prototype. The way I think about it, prototype is an experimental model of an idea.
Silence and look at the ball on the
In
place.
front of something else to see if our idea has value. As a design researcher here, I put ideas in front of people who use our products all the time. Is your idea ready to be put in front of people? Yes. In fact, in this video series, we're sharing with you several types of prototyping methods that you can use to get your ideas in front of people as soon as possible. Now, how do you know when it's right to show your idea to someone else? The fidelity of your prototype should match the fidelity of your thinking. So don't be afraid to share your prototypes early and often to get feedback to guide your next product design decision. We put together a series of 3 videos to introduce you to various techniques we use at Google. There's sketching and paper prototyping, digital prototyping with form and principle, and native prototyping. So to get things started, let's take a look at how teams at Google take an idea in their head and make the first stroke with a pen on paper.
Hi, my name is Melissa Powell, and I'm on Google's Developer Relations team. I get to work with designers, developers, and entrepreneurs both inside and outside of Google to solve some pretty tough design challenges.
And I'm Miriam Shake, a senior user experience designer at Google. I design ad experiences to make them better and simpler to use for products such as Google Search, AdWords, and DoubleClick. And we're here to talk to you about sketching and paper prototyping. prototyping and graphic design tools to create high-fidelity boxes like these.
High
But even with
fidelity.
a high-tech company like Google, we generally start the design process with something that looks a lot more like this. By the end of the video, you should feel confident knowing when to use Sketch for paper prototyping, 4 types of sketches you can confidently use in Google, and 3 primary benefits of paper prototyping. Sketching is a fundamental part of the design process and can help you make key decisions about what to design. It can be as simple as drawing on a piece of paper, or even a post-it note, or you can use any of these common materials to create a more realistic sketch and share your sketch with others. Sketching can be used in nearly any stage of the product design process. You can use different types of sketches to figure out who you're working with and what you need to communicate. Sketching is great when thinking through all of the initial ideas running through your head. You can sketch to outline the steps in a user flow, explore a variety of layouts, and to show the basic app structure, or what we commonly call a wireframe. Once you've agreed on a rough layout, we usually create high-fidelity sketches with details such as buttons, images, and color. At this point, you may decide to transfer your sketches to your digital tools, but the more you can flesh out your ideas on paper, the faster you'll move on your computer. During mid-development and even post-launch, you may need to rethink your design and want to quickly visualize new ideas. So you might bust out a pen and paper even if you already have high-fidelity digital prototypes. It can be faster to communicate and validate your new ideas through sketches before you have to make those changes.
Do you understand what Jesus just said? Even when you have high fidelity prototype, you still need to sketch a low fidelity prototype. Why is that? Because it's the most powerful tool for communication. Easier way to communicate with other people, especially when you want to communicate with the customer about the project. So don't never underestimate the paper prototype.
To your digital prototype. In addition to sketching, another low-fidelity option is paper prototyping. Today I'll cover how paper prototyping can help you think through key user interactions, use color more purposefully, and visualize elevation and shadows. And let me give you some practical paper prototyping pro tips. As you can see in the sketch that Miriam created, it's easy to visualize the user flow, but it's a little bit more difficult to understand the user interactions between the screens. You can use your paper prototype to simulate interactions. For example, if we look over here, I've pre-created some paper prototypes, and we can explore what happens when I click on an individual button. Here we have the floating action button, or the quantity, and we can actually have it drop down. And see what happens when a new screen appears, and we're looking at the checkout cart. We can also select the address, and a pop-up window will appear. To avoid carrying around your paper prototype from meeting to meeting, record these interactions with your phone, or you can create an animated GIF by taking a few stills and throwing it into Google Photos' Auto Awesome feature. It's just easier to share your ideas with people that way. Another pro tip is to print out.
You see, from the sketch paper, from the paper prototype, you can transfer them by using your smartphone and then create an animate and send that to the customer, and they will understand what you want to say very easy. You don't have to spend a lot of time to create a real prototype on the computer. Just use some pencil, use some paper, and scissors, and you can create a lot of prototypes in a very short time. See?
Screens. Instead of redrawing all the common elements over and over, the goal here isn't to test your arts and crafts skills, but to explore the interactions and natural transitions between screens. And since we're working with paper, you can also explore different principles of material design, such as color, elevation, and shadows. Material design is Google's visual design language that synthesizes classic principles of good design with the innovation and possibility of technology. And at the end of the day, it was inspired by the study of paper and ink, so why not get back to basics using paper and ink? A good place to start is to think through purposeful and consistent use of colors. The material design spec has a lot of great information about selecting hues and saturations, so be sure to explore the full material design color palette at the link in the description below. And be purposeful with your use of color, not just on one screen, but but throughout the app. In general, we recommend choosing one primary color, which is most commonly used for components such as the app bar or background, and one or perhaps
No,
two
we don't need
accent
to do
colors
it
for anything
just
that you want to
from
brand.
this one. So from this, they're saying about the technique in creating a prototype, and it's more suitable for the ID course rather than for our course. So we keep it. Forget it, and we come with the.
Attention, such as the fact.
Okay, we just have a look at the very basic prototyping, a low fidelity prototype. Now we have a look at a digital prototype.
My name is Chris Conover, and I'm a UX engineer. And my name is Rosie, and I'm a designer. If you're interested in turning your ideas into a real experience running on an actual device, then this video is for you. This is the second part in our series on prototyping. Mostly we're going to talk about sketching and digital prototyping. In this video, we're going to talk about digital prototyping. Digital prototyping is the process of exploring an idea by building an interactive experience. Explaining abstract ideas in words can be tough. By creating an interactive design artifact that other people can experience themselves, your ideas become real. Digital prototypes are very helpful when you're pitching an idea to explain the design details to an engineer or running user studies about it. Best of all, they don't require you to know how to code, which means it's fast and easy to explore many different ideas. In a way, digital prototypes are a lot like building models that architects create. An architect creates a model because it gives their client an idea of what the finished building will look like without hiring a construction crew or breaking ground. We use digital prototypes to build experiences that look and behave like the final app without using costly engineering. Over the last few years, we've seen a lot of new digital.
So when we come to digital prototyping, it can be considered like a kind of high fidelity prototype because now the prototype is created on a real machine and you can see the interaction there. However, you can see the high fidelity prototype will be matched to what we describe in your low fidelity prototype or paper prototype. And from this part, you can see people will jump from paper prototype to something like working on a machine prototype. And you can see there is instruction, however, no constraint, no exception. That means they don't check for errors. They don't check for defect. Just want to see how it works. And in some point, at some project, this kind of high fidelity prototype will become a development system. That means instead of throw it away like paper, people will try to reuse and improve that prototype to become a real system to save time. And so that kind of prototype will be meant for a brand time box.
Costly engineering. Over the last few years, we've seen a lot of new digital prototyping tools enter the market. They each have their really unique set of features and benefits. Some tools focus on helping you build out the basic flow of your app, while others are more geared towards exploring small interactions. Today, we're going to take a closer look at two of these tools and see how they can be applied. To give some background, our team is working on a fictional e-commerce app and is printing sketches and models showing the different screens. These artifacts have given the team a pretty good idea of what we're trying to build, but we wanted to have something that could be shown to stakeholders or used to test with users. I created a digital prototype to demonstrate the basic flow of our e-commerce. As you can see, we have the whole creative art concept, and I can do things like scroll through the product feed, do shopping, and I can come up here and look at this carousel of different products. And I see this clock here. Let's say I want to look at this clock and find out more about it. I can simply tap this card, and we'll transition to the product detail page where we have a description about what the product is, and we can also the action to add it to our cart. So by tapping this back button, we'll get a toast here that confirms that this Swiss railway clock has been added to my cart, and I can go back to the home screen. So, to make this prototype, I used a tool called Principle. I'd like to show you a few of the features that made it easy to create. Don't worry about understanding everything I'm doing. This isn't meant to be a tutorial, but rather to expose you to the possibilities of this tool. So here we are in Sketch.
So you can see here, in order to create prototype, a digital prototype, this developer using an automation tool and it's called Principle. In Google, there are some automation tools that help us to create prototype very quickly. And after we create the prototype, the last thing we need to do is insert some code for checking the error, and that's all. We will have an information system complete.
See, we have a static version of our designs. Now we need to import them into Principle by switching to Principle and clicking Import. And now you
So
see
this is a tool to create a prototype quickly.
This is really great because each design object that we had to over in Sketch is now available inside of Principle. So you can see inside the player list, we have access to all these different cards and different code pieces.
Okay, up to now is Google introduced about the tool, so you don't need to view it, you can see it later. And the last one is a native prototyping. It's the highest level in creating a high fidelity prototype. That's a lot. A quick look.
Thank you for taking the time to watch our prototyping series. You've seen everything from paper to digital and data prototypes. And somewhere in that spectrum is the right method to tell the story of your work. I encourage you to explore. Engineers and prototyping.
The last level is native prototyping.
Hi, I'm Carl Sieber, and I'm Coach Michelle. We are UX engineers that prototype new search experiences for Google.
UX engineer, that means user experience engineer. Engineer create to improve user experience when using a product.
At the core, prototypes are stories about the future. They help us create a shared sense of our current state, our future vision, and the path we'll take to get there. In this section, we'll be talking about native prototyping. And when we say native prototyping, we mean getting your hands dirty and writing some code. This could mean writing Android applications with Java, constructing iOS apps with Swift, or writing HTML, CSS, and JavaScript with Ruby.
You just hear that he said that get your hands dirty. That means in this file you have to insert some code into the digital prototyping. In the digital prototyping, actually there is no code. There are just animations and some code generated by the machine only. And now you have to insert the codes by yourself to create constraint for the prototype. And at this point, prototype become a very high fidelity prototype that we call native prototyping. And when a prototype come up with native prototyping, it usually become a real system development, and people will not throw it away. Because they spend a lot of time, money, and resources on it.
As much as possible, this is done using real devices, real data, and real users. Our goal for this video is to show you how you can leverage technology to really bring your ideas to life. This will let you start testing in real-world scenarios and start pitching your ideas to users and stakeholders. Now, we'll look into each of these areas in more detail and show you how they'll come together to turn your idea into an actual product. Do you know what the best thing about being a prototyper is? Toys. Lots and lots of toys. When you prototype native, you start building and testing your design ideas on real devices. Think of this as an extension of your design process. All of this technology becomes your new canvas. The code you write becomes your new paintbrush. We all know that building an experience for our phones is is one of the primary goals of data prototyping. So how do you get started? Well, as you may have guessed, this type of prototyping requires strong technical proficiency. Depending on which platform you use, this could mean writing code in Java, Swift, C++, Python, JavaScript, or any number of other programming languages.
Do you find familiar to you anything? Java, C++, or JavaScript? Anything you have in hand?
You also need to be proficient in the ecosystem and SDKs of whatever you're building on, whether that be Android, iOS, a web browser, or even hardware platforms like your Arduino. Nowadays, our devices are loaded with technology: gyroscopes, accelerometers, speakers, cameras, microphones, and the GPS are all important part of the technology to help shape the experience your user has with the product. They all are pretty hard to prototype with traditional design tools like Photoshop or Sketch, or even some of the digital prototyping tools you saw earlier. Sometimes the best way to prototype an experience is by writing code. But when you prototype, you have a much different intent. We call it the hacker's mentality. You'll be exploring, taking a lot of risks, and probably a lot of shortcuts in the code. And that's okay. I should also mention, as you conduct these explorations, this is a really great time to try out specific libraries and frameworks and assess whether they are a good fit for your product. Remember, prototyping is meant to be low commitment. Feel free to throw away code whenever you need to, and really use this opportunity to explore, experiment, and learn. In the next section, Carl will show you how you can take all your prototype explorations and start validating them with real users. Now that you've got a solid baseline of the technologies you use figured out, you need to consider how users will respond to your new features. One of the main benefits of data prototyping is to have a realistic experience that you can put in the hands of your users to provide valuable feedback. Because a new user experience is much more than just the look and feel of your application. Designing for your target market means making an investment in understanding how users will react to innovation and input characteristics of the experience. This validation, early in the product lifecycle, will help you identify features that most resonate with your users and focus your design development efforts in that direction. Integrate the simple process of design, prototype, test, and validate to your workflow will afford you the opportunity to craft workflow components. Design, prototype, test, and validate to your workflow. Integrate the simple process of design, prototype, test, validate.
Try to get this one this time. As you can see here, this is the prototype life cycle, development life cycle of a prototype. And you can see again, in the whole information system life cycle, there is another smaller life cycle for prototyping. And prototyping also requires 4 phases: designing, create prototyping, and then testing the prototyping and validate. Validate is a term defined by Google. That means validate, have you meet the requirements? Have you gone the right direction or not? Testing is about functionality. To make sure functionality in your prototyping works. But validating is about user requirement. And you can see at this point, a native prototype is almost the same like a real information system. And you can see people can save a lot of time when they change from paperwork to digital prototyping, to native prototyping, and then to the real information system. The process is simple. See? And the remaining part of this video, you don't need to do it, you can do it at home. Okay. Before we go next, any question? No. So we can take a break in 5 minutes and then we keep going.